he says, well, what can I do? And he says, well, why don't you take up skydiving? He says, I don't want to skydive. That's just too much. No, you need to skydive. So he goes to the course and he jumps off the ladder and he gets it. And so he's finally ready to get in the plane, and he's in the plane, jumps out of the plane, and he's going down and he hits the cord and it doesn't work. And he hits the other cord and it doesn't work. And he's falling down faster and faster. All of a sudden he sees this guy shooting up, goes right by him, and he says to the guy, do you know anything about parachutes? And the guy says, no, do you know anything about Coleman stoves? So much for energy jokes. So I was thinking, as Carol was talking about, this is going to go, about when I was just a kid, I asked my dad the proverbial question, Dad, what's the difference between a liberal and a conservative? And I never forget, my dad said, he put it real simple, he said, a liberal is change for the sake of change, and a conservative is change for the better. So that's what we're about. We want change, but we want it to be for the better. And so what I want to show you is not just things about nuclear power, but I'm hoping to educate a little bit on how to deal with environmental issues from a conservative point of view. How do we handle safety and the environment without lots of government intervention? And can this be done? And I believe it can be, and I believe part of it is to know the facts and to know how to look at the environment from a conservative point of view. So a couple questions we want to ask. How did nuclear power start? What makes it safe, clean, and green? What about nuclear waste? What about conservation? How do we deal with conservation? And then why is it even controversial? So I'm going to cover a lot of things. I don't know where you're at in terms of your knowledge. I want to give you some quick background, and then we'll move into some of the reasons why nuclear power is safe, but also, again, help you think environmentally. How can we handle environmental problems from a conservative point of view? So, well, in our lab back in the 1950s, this is a quick history of nuclear power, President Eisenhower initiated an Atoms for Peace program. And the whole idea was to move from atomic bombs to some useful use. And this was radical in the world. Basically, everybody thought, well, all we can do is just blow up stuff. And the Atoms for Peace program, part of it got started in Idaho. And as you can see, what came out of that was in 1952, we generated the first nuclear-powered electricity. The reason it's all in Idaho is because of the nuclear submarine. We have a testing range out there, and the government would bring in battleship guns, and they would hone them at Pocatello, and then they'd take them up to the buttes. And in the buttes, they fire them to make sure they were in good shape. Well, that was where we got the real estate the size of Rhode Island. And Rickover came out to the desert and said, this is where we're going to make a nuclear submarine. And in 5 years, he went from nothing to a powered reactor, and then as you can see, in 1960, they actually took a nuclear submarine around the world underwater continuously. An incredible technological feat because of the science and the technology of nuclear power. So it was the nuclear submarine that got the whole ball rolling. That tamed the atom. That's where nuclear electricity started to come from, and that's where we went from there. Notice in Idaho we also have the longest operating electricity producing breeder reactor, and as you can see, the highest power research reactor. And that reactor is still going today. And that's where isotopes are made for cancer treatment. All of the periodic table, all of our knowledge about nuclear isotopes, a lot of it came out of that reactor. You can see a picture there of that's the electricity producing reactor right there. That's what actually was a generator that turned the lights. And you can visit that, by the way, in the summer. Material sterilization. I remember when I was in junior high, a guy brought in some pork chops that had been sterilized by radiation, and they were just in a plastic bag, and they had been good for 20 years. And that was going to be a real boon until people decided that something was going to happen to the food that wasn't good. So But you could literally sterilize things. We used to do that with our spuds out there in Idaho. You could irradiate them and then they wouldn't sprout. Of course, when you radiate something, it doesn't become radioactive. That's one of the biggest myths ever. We used to joke, I used to say, I'm in the nuclear industry and I don't need a refrigerator light. I just open the door up and just glow. People don't realize that when you get an X-ray, you're getting radiation, but you don't become irradiated. That's one of those common myths. But a lot of technology has not been proceeded upon because of the whole nuclear, what they call the nuclear boogeyman. Noticing that the naval vessels here, this is where it got started, and all the tank armor is made out in Idaho. It turns out that the only other use for uranium besides nuclear power is when it's depleted, it makes a great shield. The Abrams tank in the Gulf War could take a 103 millimeter shell broadside and protect the occupants. An incredible amount of shielding, and none of those tanks ever were disabled by any direct shots. That's what kind of technology we get.
Could you repeat that?
Sure.
How do you get that?
The armor, uranium-238 is much denser than lead, and so by using depleted uranium, it's slightly radioactive, but it doesn't have anything that you can make bombs out of. It's uranium left over when you've made fuel, so it makes for a very dense substance. You can make a tank that's impermeable. Let's see if I can find a way to advance these things a little quicker. Now, just to show you the slide, this is a picture of the kind of technology when nuclear was invented. And I show this to show that at this level, there was still a huge amount of safety. And all of our safety things are based on this antiquated technology. So you can imagine how much better it is than when we first made up the technology. This is what Popular Mechanics said a home computer would look like. This is their projection in the year 2000. This is what you'd have in your home if you had a computer. And I thought it was really humorous because at that technology level, we were still able to make a technology that was very safe. But he's standing by your home computer of the future. Well, health hazards exist in all large-scale energy production. In fact, risk is part of life. And one of the first things you need to remember is, anytime you talk about risk, if somebody says, is it safe? You would always reply, compared to what? You always must compare. There's no such thing as absolute risk. They say, well, what if you just stayed in bed all day? Well, I was talking to Gary's wife, and you can die of a heart attack. You can die in bed. So you're always getting risk, and one of the best things is to compare risks to risk. Compare what you're doing to the benefits you're gaining, but never think in terms of absolutes. Unfortunately, our enemies always think in absolute terms. There's no such thing as that. You will always incur a risk. If you came to this talk today, you incurred a risk. And it was a small risk, but you did a risk. To get out of bed, get in your car is a risk. So that's what we always do in environmental. What kind of risk am I incurring for the benefit I'm obtaining? So that's what you always want to remember in terms of risk. Notice that we're going to deal with health hazards in mining and refining. So even if you have solar, if you have wind, you're always going to be mining, refining, building something. You're always going to have construction operation. People forget that you have, oh, yeah, question.
I thought I read someplace that nuclear energy has the lowest death rate of the employees that work on the energy per unit of energy of any other energy that we have.
Oh, that was my last slide. I'm done. Rats! No, that's exactly where we're headed. And that's well put. I don't know if you all heard the question, but we're going to look at the entire life cycle cost in terms of money, but also in terms of human life. And again, as conservatives, we value human life. We are the only party that values it all the way. And so it's important that we realize that that includes everything humans might do from the get-go. In other words, a good example, I point out to people that we went from a different kind of refrigerant in our cars, and we all thought, well, this is an environmental improvement. Well, we forgot about the fact that the worker, the mechanic, is now dealing with a more toxic substance. So there's a trade-off. He's dealing with a more toxic substance, so supposedly we would get some kind of benefit. But ultimately, all of these things, mining, emissions, waste, security, the environment, those are all incurring risks. Every power source has those kinds of risks. And the conclusion will be, how many fatalities over the whole life cycle? Everything, environment, worker safety, and that's something we usually don't think of. We usually think of one aspect. Oops.
You should be able to page up. You got it.
So I'll deal with these things. I'll try to go rather rapidly here because some of this is may not be of interest. But I wanted to give a background of how you think about a technology. So your friends, when they come to you and say, oh, this is dangerous, you can say, well, what kind of dangerous? Is it dangerous in mining? How about transportation? A lot of people don't realize that we transport incredibly dangerous things all the time, i.e. gasoline, propane. Those are essentially bombs that we're just transporting all over the place. So we try to avert the risk, but there's always a cost to that. Notice that we have our accident-free in operation, environmentally benign, secure against terrorism, and green and waste disposal. And again, people forget that I have a solar panel. When I'm done with it, I got to get rid of it. It's got toxic metals in it. How do I do that? Do I apply the same rules that I do to something else? We're going to talk about coal plants. Coal plants are more radioactive than nuclear plants. Where is that going? Is anybody containing it? Does anybody care? And just because I don't monitor the radiation of a coal plant doesn't mean it's real radiation. Right, the concentration of energy from a nuclear reaction is superior in safety. This is going to be the theme if you want to get the basic theme. It's the concentration of energy that makes for safety. Diluteness means I spread it all out and I have to kind of like herding cats. It's all spread out. Nuclear is very concentrated, so I can get a hold of the waste, and I'm not transporting a ton of stuff. Or notice that I say here that a pound of plutonium has the same energy as the Yankee Stadium full of coal. That's an incredibly different economy of scale. So everything that I do to get that coal from the mine to the factory to burn it, all of that is going to be spread out. It's going to be a huge quantity of substance. My uranium is going to be very small. It's going to be contained. Notice the comparisons. We've got a cord of wood. We've got 1,700 cubic feet of natural gas. That'll come in handy because that's the energy movement right now is natural gas. So we'll talk a little bit more about that than coal, though coal is the main comparator for electricity. Notice that I have 1 year of sunlight on 2 acres of photovoltaic panels. That's a what we call a dilute source. So every time you think of solar or wind, think of big areas. Huge, literally square miles worth of areas compared to a small plant. And hydropower, again, look how many square miles I have to drain. I have to drain 160 square miles of water to get ahead to make hydro. Okay, this is just safety in uranium mining. And again, if I'm mining, oh, back here, sorry.
When I visited your facility in Idaho, I was struck by the size of the pellets. Can you describe to this group how large those pellets are?
The pellets are like this.
About the size of a large pea.
Yeah, and that's all you need. And what you're doing, you see, is you're harnessing the atom, not doing a chemical reaction, you're doing a nuclear reaction. When I got into the field 40 years ago, that was the fascination, is you're actually harnessing a different sort of power than anything else you do. You're not doing something, you're doing what the sun does, you're doing something nuclear. That's where the leverage is, if you will. That's why it's so concentrated. Okay, real quick slide. Less mining than coal. You've got one uranium mine, you've got hundreds of coal mines. So you're going to have less accidents. Everything's going to be less just because you have accidents when you mine stuff. If you have to mine the metals for a solar panel, somebody has to mine it. They have to get it together, they have to go to a factory and make it. So you're going to not only incur that, but as we see, you're going to incur an environmental cost to do that work. Every time you assemble money, you have done something to the environment, you have done something to the ground. You can't get wealth without doing something. That's another fallacy. You don't just do it by standing there. Somebody's got to do something to the environment, do something to other people to get wealth. Just a quick comparison of uranium safety in, this is just the mining part. Notice again, it's 100 to 1. That's just the mining aspect. And again, it's just a matter of how much coal you have to get to burn it. Uranium, you're talking a truckload versus a train load. That's a lot difference in scale. This is the transport. And again, everything got to be transported. I don't know if you've ever noticed on the highway, but if you notice the wind blades being transported, anybody seen those? They're huge. Okay, you're incurring a transport cost. You have to pay for that. Somebody has to do a lot of work to get those things into place. Well, this is the fuel part. Notice the difference between transporting coal, oil, and uranium. You got a huge difference in order of magnitude. And here's the safety and transport. We did mining, this is transport. Again, notice it's 100 to 1. And every time you transport anything, you transport solar panels, you incur a cost for that energy. You don't get and if you ignore that, you're not taking the whole life cycle. So remember, in the environment, you want to do the whole life cycle. Making it, maintaining it, getting rid of it. Now this is our reactor in Idaho that you probably got to see. We're going to talk a little bit about nuclear safety, worker safety, and public safety. And again, those are different aspects of safety. One of the biggest things we tell people in the public is that I got to work with the stuff, so I want to be safe. So if the workers who are right next to it are safe, everybody else is going to be that much safer. We're not going to sit there and incur penalties, especially since we know about it. People always say, well, you're being paid by the nuclear industry. No, but I want to go home, and I don't want to get cancer, and I want to be safe. So the intrinsic safety is right to the worker first. And every other site has to worry about safety. How many times have you heard about the fatalities of fixing windmills? Nobody mentions it. Well, there's a cost. You don't go up there every day and not have somebody fall. If you're cleaning your solar panels, somebody's walking around. In fact, we did a calculation about 20 years ago when solar, individual home solar panels went in, and somebody said, well, what if every homeowner got a solar panel and had to go up and clean it every year? And we crunched the numbers, and it would be like carnage time. Because the main homeowner accident is falls. That's what kills the homeowner. And as I get older, I got to worry about falling all over the place. But climbing around on roofs is dangerous, and that would be a cost of your energy. And if you have homeowners doing it, you're going to have people falling and getting injured. So the question is that injury worth the number of kilowatts I'm getting out of my solar panel? As we will see, it's not a very good deal. Okay, now accidents, there's two kinds of ways to think about accidents. Again, this is just sort of educational. You can think about the probability of the accident. Okay, so that's what's the probability this is going to occur? And then there's the severity of the accident. So anytime you talk about safety, is the person thinking about probability? That's like, oh, auto accidents occur a lot. What's the severity of an auto accident? A fatality. But rarely does an auto accident take out a seat. Okay, so you've got probability and you've got severity. So those are the two things we think of when risk. So if we're talking about solar power and people are climbing around on these panels, the probability is rather high that somebody's going to fall. The severity, they might get injured, we might have a fatality. And we can calculate both of those things rather accurately. So again, nuclear has a lower probability of a severe accident occurring. It has a lower severity because of its small quantity. In other words, we have quite a few fossil fuel accidents already happening. We got refineries catching on fire. As you can see there, there's a fire in New York. And the chance of the accident is less than almost any other risk that we can codify. When I started the industry 40 years ago, they were estimating that there would be a reactor accident probably every year, or every other year. And we haven't had any except for 3 Mile Island. That's the only one, and that wasn't really the kind of accident they were talking about. That was more of a worker error. And bottom line is nobody was injured by the reaction, by the action itself. And so again, the severity was very low, and the probability was extremely low. So even then, even with the worst case scenario, which was a lot of blunders, nobody got injured. Now, it's a big mess. You got to clean it up. And I point out, people say, well, what about Fukushima? What about the big disaster in Japan? And I'll address that right now. I always say, well, what went on there? Where was all the death? And I said, for you to worry about the nuclear reactors and to ignore 20,000 dead Japanese is to do a disservice to what went on. 20,000 people died for this tsunami. Nobody died from the reactors. And for you to ignore that fact, that is a huge, dramatic misplacement of your fear. But that's the kind of disaster it took. And even then, the reactors, they made a mess, but nobody was hurt. Nobody was killed by the reactions.
Chernobyl?
Okay, Chernobyl was not, that's not our thing. A, that was a power producing reactor. B, I would put another shameless plug in for that's what socialism will get you. I'm saying flat out, there is no responsibility in that country for environmental anything. Every time environmentalists come to me and they say, we want more socialism, I say, go to the Soviet Union and look at their environmental record. In fact, one of the statistics that was really macabre was the biggest danger from Chernobyl, the number of killed, was not from the accident. It was having everybody move to the place where they had a conventional coal-powered plant. And they documented the number of fatalities from living in a dirty Soviet city compared to clean Chernobyl. And they actually had more people get killed. And in fact, it is a fact that they moved back. The Soviets moved back to Chernobyl because it was cleaner. And they're living in the forest there. And in fact, it was on NPR, it's a wildlife refuge. The wildlife are going nuts because nobody's hunting them. And wildlife don't care about radiation anyway, and that's another story too. But that's how bad dirty living is compared to in a new. So even though the plant was a sheer disaster, it was a power producing rack, negative reactivity, I mean, everything was not what we would do. We would never have a plant like that. Even then, it was to their advantage to have nuclear power over their coal because their coal is so dirty, their cities are so dirty. Yeah, we have 31, notice that only 31 died from immediate radiation. One of the hard things for people to conceive of is for you to die of actual radiation poisoning is you have to be pretty close and it's pretty quick. Most of the time, you're not close enough. So most of the accidents in Chernobyl were from the heat or from just regular construction accidents. The death count was extremely low compared to what they thought. And even with all the mess-ups that they did, the radiation wasn't really the big hazard. It was moving people around. In fact, notice that 3 Mile Island, there was no detectable health effect, but notice that what I point out there, 70 lives were lost because the replacement power was going to be coal. And again, people forget that every time you turn on a switch, somebody died at some rate for you to turn that switch on and get electricity. Our job is to do it the cleanest way possible, to impact the least amount of lives. Notice what we say here, the cancers from the worst meltdown accident would not be any more noticeable than the deaths from all sorts now occurring from air pollution. Air pollution from coal burning causes 30,000 real deaths per year. So there's plenty of toxins out there, we'd like to minimize them. And radiation is not one of them that are of any consequence. This is the one that gets to the question here. This is one of my favorite slides. This is a rather new slide. But notice what we put is we're going to put the whole thing in one slide here. In other words, how many people die for any kind of energy source? And I think this is pretty graphic. On average, 100,000 people die for 1 trillion kilowatts of electricity. But notice the difference. I thought this was kind of cool too. China is always a little worse because they're doing it in a socialist government manner. They're not taking all the care they need to be. So you got coal is the worst. Notice that natural gas, which is what we're using, there's a much smaller rate of death for that 1 trillion kilowatts. But there's still somebody dying. It's very low though. Notice that biomass, now why is biomass so hard? Because growing things is very dangerous. One thing I learned, I was in the biomass industry for a while. I did straw conversion to fuel. And farming is very dangerous. That's one of those things that it's nice and hometowny and we get warm feelings. It's a dangerous activity. And that's why that number is so high. Anytime we put people with all kinds of farm machinery running around, there's accidents. Notice that solar has a worse record than natural gas because we have lots of area, people climbing around. Hydro is dangerous in the building, but notice that the global electricity compared to US. We have much better worker safety. And again, worker safety is part of the whole package. People gotta climb around, pour cement, they fall, all that kind of thing. I think the interest here, you wanna see, I mean, look at the difference between global and US in nuclear. Global and US in terms of hydro. As much as we criticize our government, we still take extra care and we do things better than the rest of the world. Are we perfect? No. Remember, we compare risks. We cannot be perfect this side of heaven. We all know that. But that's what we want to do. We want to minimize those. But remember, anytime we spend money, that's also a risk. I'm taking money from one source and I'm putting it at another. So you never have a free lunch. You never get money for nothing. No, there was an environmental cost for you to take the money and do something with it. Notice that it costs 2,000 lives per year to keep the lights on in Beijing, but only 200 lives per year to keep them on in New York City. So again, that's part of our market system. That's part of the American way of doing it safely. But you need infrastructure. You need people that care about it, and you need people that take an interest in, take a responsibility. Notice that's a steam coming from a nuclear plant. And by the way, way back when I started this game, I had an article from the Sierra Club magazine, and they were advertising how clean nuclear was back before they got onto the anti-bandwagon. And it was incredible because think back then, nobody had ever seen power without smokestacks. You put up with it because you wanted electricity. You put up with air pollution, just the way you live. I lived in Pittsburgh. We had lots of air pollution. If you wanted industry, if you wanted steel, you just put up with it. There's our energy breakdown today. Notice the nuclear has stayed pretty much constant, but notice the amount of natural gas. Natural gas has really helped a lot of ways because it's less burning of coal. But again, nuclear, as I'll show you, is even cleaner than natural gas, which is pretty amazing, but that's how clean we run the show. What does nuclear power emit? It doesn't emit a lot of stuff. It doesn't emit mercury, hydrocarbons, sulfur dioxide. All of those are emitted, and remember, they're emitted when you use coal electricity to make a solar panel. If I use coal electricity to make a wind turbine, I'm going to emit those things. And I'm going to emit those when I pour cement. So if I make a nuclear plant, I got a lot of cement. But guess what? If I make wind turbines, I got a lot more cement. Because I got 50 square miles of cement I got to pour. As I'll show you. Okay, nuclear plants emit no air pollutants, while every ton of coal burned must be emitted as waste. So again, the waste is always being emitted, but we're just not containing it. When we burn it, we just go to the air, just whatever. Nuclear has always maintained control of their waste. Now, we've improved a lot, but we've always said, we're going to hold this, we're going to hold on to this. We're not just going to let it go. And that's one of the big differences between all the other power sources, is they just took coal waste and just dumped it. I mean, whether it was more radioactive or not. And it turns out that coal waste is actually more radioactive than nuclear waste, which is, but it's not regulated. I just put this picture in so we could see the way it was. This is the good old days. Notice that this is in St. Louis in 1939, and this is the great outdoors, and people would put up with this. In London, you just put it up with a lot of air conditioning, because that's what you needed to run the city. So here I compare the waste from a coal plant and an oil. Notice the CO2 numbers, and we're going to talk about CO2, since I'm sure that's probably going to be on your mind. I won't get into hopefully not get into too much intricacy, but there's a lot to be said about CO2 emissions. But look at the difference. Nuclear is essentially, it's zero all the way down the line. And notice that there's, this is emissions from operations. We're going to get into emissions from building it up. But you can just see the comparison. Oil is better than coal, but we still got numbers there. And if you wanted to be really clean, you can tell your anti-CO2 friend, this is the only way to go. I wanted to put this in here just so you get a feel for radiation. You got to have a little bit of radiation knowledge so you understand that you're right now, I hate to tell you this, but you're irradiating the person next to you. You're exchanging millirems as we speak. Every time you sleep with your spouse, you're irradiating each other. It's low, but you are. We live in a sea of it. It's hard, again, there's no absolute, the only absolute place that's free of radiation is the submariners underwater. They're about as low as you can get. In fact, a lot of the submariners that were dealing with nuclear reactors, they actually had negative radiation because the radiation from the reactor was less than the cosmic radiation, so they were actually getting less than they would if they were on land. You're getting about 300 millirems a year. So, and there I just showed, notice that radon, that's the biggest one. And unfortunately, that number had to be increased because as you seal your house up, you're sealing in the radon. Now, that's just the way radon is. It's coming from the building materials. Notice that nuclear industry is way up here in the little corner there. We get a lot of cosmic. We have a lot coming from a body. The main, go ahead, question?
I did.
Oh, the main nuclide, by the way, is potassium. So show people a banana and say, this is probably the most radioactive thing you eat. If you take potassium iodide for iodine, or you take potassium pills, you will get 35% of that, more or less of that, is a radioactive isotope of potassium. Potato is radioactive, beer is, so there's all kind of good stuff out there. Go ahead, Carol.
I just wanted to say that radon is, it's there all the time when your house is closed up, but it can be there on Tuesday, and if you open your windows, it's gone,
Yeah.
it goes away. So open your windows on a nice day like today. Peter?
Yes.
They're building a whole district in Arizona in granite, which is radon stuff, and inventing them.
In fact, what happened in Maine, the rock is so radioactive that the worst thing they ever did was seal up their homes. They were saying that the leaky homes did what Carol said. And so now you have to put a heat exchanger on. I built a home for my pastor, and it was mandatory. It was so sealed that you had to put a heat exchanger and you ventilate that. But that's the only way to get rid of radon. But radon's around, and it's a result of just natural building materials. So our bodies are used to radiation. It's not like, oh, I never heard of this. All right. Here's an example. And again, peanuts have potassium. So when you have potassium, you're going to have radioactivity. Notice that the power plant's cancer contribution is equivalent to eating an extra helping of peanut butter. Now that sounds like hyperbole, but that's how low we're talking. We're talking about not only do you have to have the toxin, but here's another point. You have to have a vector to transport it. So every time somebody says, oh, this is toxic, the question is, how does it get from there to me? That's the key point. Somebody pointed out that there's enough safety pins made every year to kill the. You have to have a vector. And it's very problematic because if you don't have a vector, the toxin's not going to do anything. Just sitting there is not going to do anything. And solar panels are very toxic. They have lead in them, they have selenium, they have all kinds of toxic metals, but we don't think of them as toxic. There's no vector to get that from them to me. And so that's a problem with all kinds of toxins, is you gotta have that vector. Notice again that the coal ash is radioactive. Hazards of other emission-free, now these are emission-free energy sources, so now we're talking solar and wind. They require two things: large amounts of material and large land area. We're going to talk about that a little bit so you can see the comparison between a concentrated source like nuclear and a dilute source like solar or wind or biomass. Remember, we're talking megawatts of electricity here, and we're going to measure everything by how much electricity is. Not by how I feel about it, but does it produce the goods? And that's one of the most startling things. I did solar panels at my house, and I was surprised at how dilute solar is. It's not a lot of energy for the area you get, because the sun is just what the sun is. I can't make it more than it is.
I have a question.
Yes. Yes.
Yeah, so tell me about San Onofre and the reactor that failed there, and that power plant that has 2 or 3 reactors, and the containment facilities that have all that nice nuclear waste in them, and 0 energy is being produced.
Right. And they're the operational accidents. His question was about San Onofre, and there's been some reactor accidents, and there's been some waste generated. And that's just standard. Again, the waste is contained, the operators aren't in there, and I would submit to you that probably, I know almost for sure, the electricity that San Onofre produced in its lifetime way made up for the fact that it's going to cost some money to get rid of that waste and to clean it up.
That's a safety issue, and maybe it can be
Yeah.
resolved, and maybe it can't.
Right. And again, we're talking worker safety. Now, we always have worker safety to worry about. And there's always going to be dangerous things. In fact, when 3 Mile Island happened, the very same day, an oil refinery blew up and 400 people died. It never made the news because it's so normal. Energy, a tanker truck has an accident, the guy dies. We don't even think about it. So energy is going to incur a risk. We're never going to be risk-free. We're going to have the money to clean up our messes. Fortunately, with our economy, we have the money to clean stuff up. In the Soviet Union, they did not have any money to clean it up. In fact, Europe is funding all the Chernobyl cleanup. So he said, I worked in defueling nuclear submarines, and I asked my professor when I was taking the training course, what did the Soviets do to defuel their nuclear submarines? They don't. They just sink them.
They bury them.
They just don't have the money to do it. We're the only country that does it with all the money we put in. So, good question. Okay, this is a land area, and I want you to get a feel for dilute energy versus nuclear. Notice the square miles I need with solar panels. I need 40 square miles of land to produce the electricity equivalent of 1 power plant. And that's got to be maintained, it's got to be operated, it's got to be cleaned, and then we have to get rid of all those. About 20 years, those panels are done. We got to get rid of them. Notice the wind turbines about the same. Biogas, bioalcohol. This is the kind of farming we have to do. So it sounds cool, but you got to think scale. You got to think kilowatts. There's going to be a lot of farming going on. Bio-oil. I worked in biomass field. The biggest problem the farmer has is he's got lots of stuff there, but how do you concentrate it so he can get it to market? Farming is a transportation issue. The farmer must add value because as soon as he puts it on a truck, the value goes down. The biggest problem we have, you're going to take straw and make fuel out of it. As soon as that straw got on a truck and went 100 miles, he used up more gas than the straw was worth. So the farmer really has a problem adding value. And guess what? Farming is in rural country. Think of that. So you got to transport. Think of transportation, think of whole life cycle cost. And there's our, again, these are equivalents. And this is almost unthinkable to have this kind of area. You're talking, this is just to replace the nuclear plants. There's a huge amount of area, and we would never do that. Now we have some marginal area, but again, every time you use marginal land, you have a greater transportation cost. You can't get it any other way. As soon as I transport something, I incur a risk, and I have loss. And those are all magnifying costs. One way. Okay, now I get into some material here. And this is, again, just for your interest, what kind of material goes into a solar plant or a wind plant? Remember, material costs money, which incurs a risk. So you can see how much energy I need. Now think energy, you should think, oh, I'm going to emit CO2. And one of the conclusions that it's really startling is nuclear emits less CO2 for its life cycle than solar or wind. So if you really have a hang up with CO2, nuclear is the only way to go if you want to minimize your CO2. Because you got to build it. You got to build your plant. You got to emit CO2 to build a wind plant. You can't do it CO2 free. Notice the material there. Lots more aluminum, concrete, glass, all that kind of stuff. And you have your energy costs. So you have material costs and energy costs. So what about climate change? I'll just use this slide. Climate change mainly deals with CO2. If you are going to go that way, you want to minimize CO2. The only proven technology that really minimizes it in terms of close to zero is nuclear. Notice what I'm saying here. The primary source of CO2, non-CO2, for 30 years we have not been emitting CO2 with our nuclear plants. So we've been doing this for 30 years. Nobody else has not emitted CO2 for 30 years. And that's a pretty amazing thing. Notice that the amount of hydro is big. We got more wind, but the next slide will show you, and this is rather startling. This is the amount of CO2 I produce when I produce electricity by all these methods. And this to me is pretty startling. Yes, coal is the most. Oil's next, yep. Notice natural gas is lower. For you chemists out there, you know why that is, don't you? Because it makes water vapor instead of carbon dioxide. But notice that renewables are way more than nuclear. And you say, well, why is that? How can they emit CO2? You've got to build a square mile plant. You can't build it without emitting CO2. So nuclear is so concentrated that life cycle will emit less CO2. So if people were serious about climate change, they would be serious about nuclear. And I said at the beginning of the whole argument, I said, if people are serious, they will talk to me and we will see if we can get nuclear going. If they're not serious about nuclear, then they can't be serious about CO2. Because I can demonstrate that I will not emit CO2. Nobody else can do that. Because CO2, again, we're fissioning uranium. We're not burning anything. Again, this is another way of looking at the graph. Notice the amount, this is CO2 for every kilowatt produced. So we're saying the same thing over again. Notice how much coal emits 0.99. Notice that nuclear is actually emitting less than wind or solar. Not a lot. It's still less though. Now there are low emissions, but if you really want to get rid of CO2 and you want to do it with a proven technology that doesn't take up your entire state, that would be the way to go. And again, this is the whole cost. This is the cost of building it. You got to transport it, you got to set it up, and then you got to maintain it. That includes driving trucks out to it and the whole bit. So I'm going to do a little bit on waste, and you've probably seen some of these before. Notice this is how we store it. When I worked for the Navy, we had canisters even bigger than that. Storage is not a problem. It's trivial. Storing it safely is trivial. Again, because it's concentrated. The problem is basically political. You don't have a problem in getting it done safely. It's a problem of politics.
How tall are those casks?
Those casks would be about 30 feet.
Oh.
They would be, the ones that we built for the Navy fuel was about this big around and twice as tall as here. So there's cement canister, and then there's a layer of, and we make this really dense cement. We put a lot of iron in it, and then you have a steel canister. We weld it, and it's double welded, and it's quite an operation. And those can be stored for as long as we have to, until we get up a buy-on. Now transportation, again, you're going to have transportation accidents, but if I transport less material, I have less impact. Every time I transport propane, you got a bomb going down the street. And nobody says we should stop transporting propane. You have a propane tank behind your summer home, that's a little bomb there. You're living with the risk, but yeah, that can go. And notice we've had quite a bit of safety. And again, part of the safety is intrinsic to the fuel. Part of it is we engineered it in there. So we've done two things, intrinsic safety and engineered it in. Okay, I'll go quick through Yucca because you know most about that. But notice again the layers of safety. One of the things that nuclear industry has always dealt with is what we call defense in depth. We're going to have this defense, and then if that goes wrong, we have this defense, and if that goes wrong, we have this defense. No other technology has done that because a lot of technology didn't even think of it. When they first built a hydroelectric plant, nobody ever said, well, what if this fails? What's my backup plan? I don't know. It just better not fail. So defense in depth, and that comes at a cost. And now this graph looks busy, but let me assure you that what we're trying to show here is that nuclear waste decays to the point where it is no less radioactive than the ore which it came out of. So it's getting better and better as I speak to you, but no other waste gets better and better. If I take a solar plant, it has all kinds of lead and arsenic and selenium, and I dump it in the ground, it will always be the same toxicity for the rest of its life. But my nuclear waste will gradually get less and less. And so notice that in thousands of years, notice that, in 1,000 years, I'm actually less than uranium that originally mined. So you don't have to store it for 20,000 years. You pretty much have to contain it for about 1,000. Your waste is down there. But again, we're talking a small amount of waste that's contained. Yes, we have waste. Waste is toxic. Everybody makes waste when you make something. You can't do something without making waste. In fact, that was the joke when I had a messy room. My mom would say, "That room's a mess," and I'd say, "Mom, I'm creative." Okay, almost done here. Okay, quickly on lethal doses. Notice that as the nuclear waste decays, it becomes less lethal. Notice that potassium cyanide, arsenic, copper, they just stay the same because there's no decay. Okay, we'll finish up here real quick. Okay, this is just showing again the waste. The nuclear waste is really a non-issue in terms of safety. It really is way overblown in terms of coal waste. Notice the solar array waste leads to 2 cancer deaths each year. That's not counting the disposal. So there's other things. When you make a solar panel, you got all kind of toxins when you make the panels. You clean them, you have solvents and all that kind of stuff. Okay, real quick, what about conservation? Well, the answer is it doesn't produce energy. I urge you all to conserve, but you still got to make energy. Conservation doesn't make anybody energy. It just saves what you got. Okay, that's a busy slide, but notice that oil and natural gas has other uses besides making electrical power, namely transportation. And there's no way that we have any better way to get ourselves around than oil. But uranium has none. That's it. It's good for armor and it's good for generating electricity. This is the last one. Again, this is what I call the nuclear dilemma. And real quick, why are you spending so much money on nuclear if it's not dangerous? And I get that question all the time, and I've lived with it for 40 years. They say, you must be blowing smoke. You wouldn't spend that much money if it wasn't dangerous. Au contraire, I would. And here I show I do. That's how much money DOE has spent on high-level waste disposal. That includes all the Yucca Mountain build. And that's how many lives you're saving for that kind of money. Look down here. If I want to save money, I just have to clean up water. I just have to clean up malaria. I have to immunize against measles. That's the kind of chilling thing that gets me as a conservative. There are much better ways I can spend my money if I really want to save people than dinking around with that kind of expenditure. That's just not right. And here's my last little joke. For you chemists, it says, don't move or I'll fill you with 98% lead, 1% antimony, 0.75% silver, 200 parts per million nickel with trace amounts of cobalt and other components below their respective detection limits. The other guy says, wait a minute, are those values certified? point being that the toxicity of the bullet isn't the problem. It's the impact of the bullet. And these are some of the problems that we face. Communication of science has been very abysmal. Education about nuclear technology is not going too good. And our association with nuclear weapons, we cannot seem to get over that association. And then fear of something new. And again, if it's changed for the better, we're all for it. And then a worldview, and this is where it gets really dicey, because it's how you look at the world. And if you're looking at the world and you're kind of anti-technology, part of the problem, I think, is that nuclear kind of symbolizes technology, and if people are anti-technology, then we take the hit. Somehow we've done something really evil. And there you go. Thank you. Oh.
Is there any recycle potential for nuclear fuel?
Oh, yes.
Yeah.
That's a whole nother issue on recycling. It's a travesty that you take plutonium, which is one of my favorite substances because it's so energy intensive. We will recycle aluminum cans at kind of a penny a can, but plutonium is worth way more than that. In fact, Gary has a sign up here that shows if we recycled our nuclear fuel, the nuclear fuel in Nevada at Yucca Mountain would be worth $14 trillion. I mean, a tremendous amount of energy. I recycled the submarine fuel. We were recycling it until the government stopped us doing that. And there's all kinds of energy potential. But it's a real political problem. Yeah. Yeah.
Can the recycled pellets be used for lifter reactors?
Yeah, and that's a really good question. I'm sorry.
Eliminates all the accidents.
Right. There's a whole bunch of new technology that I didn't want to get into because it's pretty technical. But we've got way better reactors than you're seeing here. So this safety record is incredible. But we have a reactor. We proved it 20 years ago that they just let it go. They just let the reactor run. They walked away, and the whole thing shut down. It needs no safety equipment. Those have been in design for 20 years. We got reactors that process their own waste. So there's lots of technology if we could get over the radiation home. Good question, though. Anything else?
Thank you so very much.
Yeah, I think she was asking about Palo Verde. I think it's closed. Most of the time, there's not enough incentive to open them again because of the political problems, especially in California. It's pretty hard to open one. So you incur a cost. Sorry.